Where is this going to go next? Let's find out. Moving on. An equivalent derivative formula. So it turns out the formula we've been using, which is actually what you see right there, that's not the equivalent derivative formula yet. That formula right there is where we begin. Obviously, it's based off of our exploration earlier in our discussion here, that we take the limit of the slope for a secant line to find the slope of the tangent line. But it turns out, as we move forward, we're going to need to rewrite this formula a little bit in order to take the next step. We won't see the usefulness of it until we get to 2.8, but we'll just kind of recognize, okay, this isn't going to be good enough for where we want to go with our derivative formula. Just kind of take my word for it, I guess, right now. So here's what we're going to do. We're going to introduce a new variable and we're going to rewrite things a little bit. It's going to be equivalent to what we see, but, you know, let's see where this goes, kind of, right? Okay. We're going to introduce the variable h. We're going to let h equal x minus a. You notice that x minus a is our denominator. We're going to say that's now equal to h. Okay. What are the implications of letting h equal x minus a? Well, it would follow that x is equal to a plus h. It's not really all that like mind-blowing, right? If h equals x minus a, then we add the a to the other side, and okay. But what that's going to do and why that's really clever, we are going to be able to replace the entire denominator with h, and we're going to be able to replace this x right here with a plus h. Okay, big deal. All right. Also, what about the limit, right? We have the limit as x approaches a. Notice that as x approaches a, that's the same as h approaching 0. Why is that? Well, if h equals x minus a, then if x gets closer and closer to a, when you subtract them, then the difference is going to be getting closer and closer to 0, right? As these two numbers get closer to one another, then you subtract, obviously, that, you know, the h, what it's equal to, will be getting smaller and smaller and smaller down to 0. Okay, so what we'll be able to do is replace this limit as x approaches a with a new limit as h approaches 0, and there's our new formula. So we're still going to call it f prime of a, but now we're going to take the limit as h approaches 0. That's effectively the same, you know, with this equivalence here, h equals x minus a. We're going to replace x with a plus h. We're going to keep f of a the same, but then we're going to change x minus a just to be h. And again, it's kind of like, why are we doing this? This looks more complicated than what it was before. I was perfectly happy with that formula. In fact, I was even just getting used to it. And now we have a second formula that's more complicated. What's the deal? Again, you got to wait to 2.8. Sorry, that's the way it goes. Let's try out using this new formula. You know what? We can probably make some sense of things right here. If you just look at this part of it, does that remind you of anything? It kind of looks like the difference quotient, right? I mean, we've got an a there where the difference quotient uses an x, f of x plus h minus f of x all over h. That's the difference. Well, okay. Well, a is an x value. All right. Okay. Let's try out this new formula on those same examples we had a moment ago. X squared plus 2x minus 1 equals 3, and the square root 1 Switch cameras. Okay. Find the derivative with our new formula. Part A, f of x equals x squared plus 2x minus 1, a equals 3. Our new formula is f prime of a equals the limit as h approaches 0, f of a plus h minus f of a all over h. Okay, let's see what happens. First thing, again, I'm just going to replace all of the a's with 3. Notice the limit is always h approaches 0. That never changes. A is not involved in that. And we have an a there, and then our f of a. Okay. So what to do? Well, we'll have to figure out f of 3. That's the same f of 3 that we did previously. That's going to end up being 14 here. But there's something else. We need to figure out f of 3 plus h. Let's do that on the side. That's going to take a little bit of work. I don't want to have to copy all the other stuff at the same time. F of 3 plus h. So I'm going to replace the x's with 3 plus h. So we got 3 plus h squared plus 2 times 3 plus h minus 1. This part here, if we FOIL, I don't need parentheses. It'll be 9 plus, happens twice, let's see, 6h plus h squared if we multiply it all out. And then plus 6 plus 2h minus 1. And if we combine like terms, I'll put the h squared in front. And 6h and 2h is plus 8h. And then we've got 9 plus 6 minus 1 is plus 14. Okay. All that's going to go right in here. And because maybe we've had some practice with the difference quotient, kind of set up well for this. So h squared plus 8h plus 14, right? But then we got to subtract f of 3. Well, right, plug 3 in, you get 14. So we're just going to subtract 14, and then it's all over h. Interesting. Okay, well, we have it all set up. Let's see what happens. The 14s cancel. We can factor out an h. H plus 8. H's cancel. The limit as h approaches 0, h plus 8. And at this point, we can plug in 0 for h, and our answer is 8. Hey, well, it's the same answer we got before. We knew we were going to get the same answer. We're just doing it with a different method, excuse me, with a different formula. Wow, that's pretty sweet. We won't find the equation of the tangent line. It would be the same as what we did previously. So we're happy with this. We got the slope to be the same thing. Wow, with this new formula, that's pretty cool. Okay, let's try part B with the square root. Square root 2x plus 3, a equals 11. Okay, with the new formula, we're going to be finding f prime 11. It's equal to the limit as h approaches 0, always limit as h approaches 0. Then we'll have f of 11 plus h minus f of 11 all over h. Okay. As we go about this, we're still going to have to use a conjugate, but let's kind of see how this goes. All right, so we've got f of 11 plus h. I don't think there's really any reason to do anything on the side. We're going to plug that in. It's going to be, let's see, multiplying by 2. I'll just go for it. Well, you know what? I thought it was a little bit simpler than I'm going to do this on the side. F of 11 plus h. So that's square root 2, 11 plus h plus 3. That's going to be 22 plus 2h, and then plus another 3, 25 plus h. Okay. Okay, now we're good. F of 11 equals the limit, h approaches 0, square root 25 plus h minus, we need f of 11, but same as before, that's going to work out to be 5, and then it's over h. Okay, we're set up pretty well. From here, well, we need a conjugate, right? Conjugate of our numerator. You know, we kind of notice that either formula we use, although the details are quite a bit different, we still have to use that same basic strategy of a conjugate. Similar, in the last problem, it was quite a bit simpler. We still had to factor. Right, back over here, there was still a factoring of h, although it was quite a bit simpler of a factoring, it still was there. Ooh, that's kind of cool. Here we have the conjugate. Whether it's simpler or not, I'm not sure in this case. Okay, let's see. It's about the same. So multiplying those, 25 plus h, and then the outside and the inside cancel, and then we have outside minus 25. The denominator, we are not going to distribute. We're going to keep it just as it is. H times this quantity, because, check it out, the 25s cancel. We're left with just h over all this, and now we want those h's to cancel to avoid the 0 over 0 limit. Now, when the h cancels out, we're still left with a 1. All right, okay, so get it down to that. And finally, we can plug in, and we're always plugging 0 in for h. Pretty cool. Okay, so 0 goes in. We've just got the square root of 25. So let's see, square root of 25, 5. 5 plus 5, 10. Is that what we got before? Oh my goodness. Wow. I made a huge mistake, and maybe you noticed earlier, you might have caught it. This should have been a 2h. Oh, wow. 2h. These are all 2h's. 2h, 2h, 2h. This is embarrassing. So this is 2h. When you multiply them, that all still cancels. So when the 25s are gone, that leaves 2h over h. Those cancel. We've just got 2. Aha. Now it's 2 over 10, 1/5. There it is. and make it look like I always do everything correctly with no mistakes the first time through. I'm not, though. I'm going to leave this. We need that, that realism here. Hey, we got it. Had to fix it. Good thing we knew the answer already for that one. And we could go back and correct that misdistributed 2. We got it. All right, you guys. Let's stop this video here. We got one more example in the next one.